higher. See, this is problem regarding the complex number, but I'll say this is the application of complex number in the coordinate geometry. Okay. So before going to solve this particular problem, let us discuss some basic theory. Okay. So just recall the equation of a circle. So what is the equation of a circle? So we'll know that circle centered at alpha comma beta and radius r is actually x minus alpha whole square plus y minus beta whole square is equal to r square. So that's actually the equation of a circle we all know. So now here we also know that complex number can also be represented by a order pair x and y. X plus iy, it can be represented as x plus iy. So here we consider two complex number. Okay. So let my complex number z is equal to x plus iy, and for the we consider another complex number. Let us consider z1, that's actually alpha plus I beta. So now what happened? You can see that z minus z1, that complex number, is actually x minus alpha plus I into y minus beta. So from here what we understand, that's imply that mod of z minus z1 is equal to x minus alpha whole square plus I into y minus beta whole square square root. Now, if I want to compare these two equations, we can easily imply that then the equation of a circle for the case of a complex number is actually z minus z1 into r, where z1 is the center, r is the radius of a circle. Now, we'll use this theory to solve this problem. Then it became very easy. So, come back to this first equation. So it's case z1 equal to 9, mod z1 equal to 9. That imply that mod z1 minus 0 is equal to 9. So comparing with that, we can find that it's a circle centered at 0, 0, radius, let's consider at r1, and that's equal to 9. Consider the center as c1. Okay. So first thing we understand, it's in circle. Let's go ahead and discuss the second circle, because you can see that second circle is also 3 minus 4i. So therefore we can write that z2 minus 3 minus 4i is actually equal to 4. So that can easily be written as mod of z2 minus 3 plus 4i, that's equal to 4. So which is imply that it's a circle centered at, let's see, 2, and that is actually 3 comma 4, and radius is equal to r2, and that's equal to 4. So that's the representation of two complex numbers. So the complex number z1 will be on the perimeter of the first circle, and z2 is the perimeter of the second circle. Now we have to find out the minimum distance. So here let us notice that, did we find that they intersect, they intersect, or they are away from each other? What is the condition? To do so, first find the distance between the two radius. So that means c1, c2. So what is c1, c2? That is definitely 3 square plus 4 square square root. That is actually 9 plus 16, and that's equal to 25, and that 5, which is actually gives you r1 minus r2. So what that mean? It means that both the circle actually touches each other internally. So let's see that, right? What is happening for the circle 1 and circle 2? So therefore, the first complex number z1 lies on the circle, and the second complex number z2 lies on the circle c2. And you can see that c1, c2 is actually the difference between the two radius, so therefore this touches internally. So what is this z1 minus z2, mod of z1 minus z2 represent in complex number? It says that the distance between the two complex number. So suppose my complex number z1 is here, and the second complex number z2 will be here. So therefore the distance z1 minus z2. Now say that what is the minimum value? So they always have a minimum value at the intersection point, because when they are at the intersection point, obviously that z1 minus z2 are 0 because they are the same point. So as they are touches internally, we'll say that as both circle touches internally, so mod of z1 minus z2, that is actually distance between Z1, Z2 is equal to 0. And this is, I write, minimum of that, right? So minimum of Z1, Z2 will happen, and this minimum value happen at the point of intersection. So therefore, we'll say that minimum value is actually option D, and that's 0. So this is called the application of complex number in coordinate geometry. So always remember this stuff, okay? That what is the equation of a complex number in, equation of a circle in complex number. Hope you understood this problem. Thank you.